Now let's look at some examples of graphing higher degree polynomials. Okay, our first example is a cubic. I know that because there's an exponent of 1 here, and 1 here, and 1 here, and when I add them all up, I know that this has a degree of 3. Okay, I'm going to look at my leading coefficient. I'm going to say, all right, well, there's a 1 in front, a 1 in front, and a 1 in front. 1 times 1 times 1 is 1. So the leading coefficient is 1, and that's positive. All right, I'm going to look for my zeros. The value of x that makes the first factor 0, that's that. The value of x that makes x 0 is 0. The value of x that makes the second factor 0 is negative 2. And the value of x that makes that third factor 0 is positive 1. So I have zeros at 0, at negative 2, and at positive 1. So I'm going to go ahead and note those on my graph. I also need a y-intercept. So I'm going to let x be 0, find q of 0. So I have 0 times my second parenthesis would be 2, my third parenthesis would be negative 1. 0 times 2 times negative 1 is going to be 0. So my y-intercept is at 0, and I could have noted that already because I had already put a point where y is 0. All right, my degree is odd and my leading coefficient is positive, which means that my end behavior is the odd degree gives me 2 separate directions, and then the positive leading coefficient means I'm going to start low on the left and end high on the right. Okay, so my end behavior, the way I would write that is I would say as x approaches negative infinity on the left, f of x is going to also approach negative infinity, and as x approaches infinity on the right, f of x is also approaching infinity. Okay, well now I have a lot of information. I'm going to start low because my end behavior is low on the left. I'm going to come up through my first 0, down through my second 0, and up through my third 0. And I've graphed a cubic, okay? All 3 of these zeros have a multiplicity of 1, 1, 1, 1, so my graph went straight through each 0. There was no funny business. Okay? This is another cubic, all right, because I have 3 x's here, so my degree will be 3. But because of this negative sign here, I know that my leading coefficient is going to be negative 1 instead of positive 1. What that means is instead of going up from left to right, I'm going to go down from left to right. So I'm going to start high and end low. All right, and that means my end behavior is going to be switched from the previous example. We're going to say as x goes to negative infinity, f of x is going to go to positive infinity. And as x goes to positive infinity on the right, f of x is going to go to negative infinity. My function will go, so I'm going to put that negative sign there, my function will go down on the right now and up on the left. My zeros were roots. The value of x that makes the first parenthesis 0 is 2. The value of x that makes the second parenthesis 0 is negative 1. And the value of x that makes that third parenthesis 0 is negative 4. Note that each one of these parentheses is only repeated once, so they all have a multiplicity of 1. Finally, my y-intercept. I'm going to find a of 0, which means I have a negative, and then when I put 0 in the first parenthesis, I have a negative 2. 0 in the second parenthesis gives me positive 1. 0 in the third parenthesis gives me 4. So negative 2 times 1 times 4 is negative 8, but then I have this extra negative out front, which I have to account for. So now I have a negative 8. which is positive 8. All right, let's mark everything up on our graph. I have zeros at 2, at -1, and at -4, right there. I have a y-intercept at 8. Let me see if I have room for that. 1, 2, 3, 4, 5, 6, 7, 8. I can either sneak it there, or I can count by 2's. I'm going to count by 2's. So I'm going to say that this is 2, and then 4, 6, 8, and I'm going to put it like that. Okay? You can mark your y-axis however you want. Just make sure that you give some indication of what you're counting by. All right, well, now I've marked all the things, all the points on this graph. I'm going to start high and then go low. So high on the left and low on the right. I'm going to go straight through because I had a multiplicity of 1. I'm going to turn around and come through there. I'm going to hit that 8, and then I'm going to turn around and go all the way down. All right. You have a lot of information about these graphs based on these pieces of information that you can find, the end behavior, the zeros, the y-intercept. The one thing that you will not be able to find in this course is how low this minimum value is right here, all right, and how high this maximum value is right here. Whoops, I'm moving that around for some reason. All right. You can't tell how high and how low these turning points are without the use of calculus. So we're not going to try. We're just going to say, as long as you go through the zeros properly and through the y-intercept properly, I'm not going to worry about how far, how low these turning points go. All right, let's look at another one now. In this function, e of x, I know that my degree is, well, this is x to the 5th right here, and then another x. So if I add up all those x's, I get 6 x's altogether. All right. My leading coefficient is -3. So my end behavior is going to be based on my general shape of this polynomial. An even degree with a negative leading coefficient, both ends are going to be the same direction, and because it's negative, they'll be going down. So my general shape is down on the left and down on the right. So we say as x goes to -infinity on the left, my function will be going down to -infinity. And as x goes to +infinity on the right, my function will still be going down to -infinity. All right. My zeros are -2, and that has a multiplicity of 5. That -2 is repeated 5 times, and then also 1, which has a multiplicity of 1. And then finally, my y-intercept, if I let x be 0, if I find e of 0, I'm going to have -3. 0 plus 2 is 2, but that 2 is being raised to the 5th. And then 0 minus 1 is -1. So I have 2 to the 5th, which is 32 times 3. It's getting out of control. I'm reaching for a calculator. 32 times 3 is 96. So I have -96 times -1. This is going to equal +96. That's a lot. I do not want to write 96 little tick marks here, so I'm just going to say, oh, I have a y-intercept at +96. I have zeros at -2 and at 1. I'm going to start low, and I'm going to end low, okay? If I have an odd multiplicity, a multiplicity of 5, then I know that at -2, that has that multiplicity, I'm going to even out. All right, I'm going to level out. The higher the multiplicity, the more I'm going to level out. So now that I have all these pieces in place, let's draw this function. I'm going to start low. I'm going to come here, I'm going to level out. I'm going to go up, make sure I go through 96, and then I'm going to swoop back down here and go straight through the root at 1, and it goes straight through because that one only has a multiplicity of 1. So I have something that looks like this. And again, we're looking for a general shape here. I want to know that you've gone through the roots, that you've gone through the proper y-intercept, and that you have the correct end behavior.